Okay, so the past few days this week we have talked about sample space, which is how we find our total number of outcomes. We built upon that to find simple probability, which is just the probability of one event occurring. The simple probability we learned turned into be theoretical probability, which is what should happen in theory. And then we compared our theoretical probability, what should happen. Like, for example, when I assign homework, I should have 100% turn it in. But when I do the actual experiment of assigning the homework and seeing who turns it in, it's really like 50%. So now we are moving on to the next component of probability, which is compound probability. Now, compound means two things being put together, so instead of just finding the probability of one thing like we have been doing, we're going to find the probability of two things. And there are a couple keywords that we need to look for so that way we know what operation we're doing. So the first event we have with compound probability is our ORs. So a compounded event is an event consisting of two or more simple events. One type of compound event is called a mutually exclusive event, which is an OR event. Two events that can occur at the same time and have no common outcome. This means that one does not depend on the other. I'm happy, so either one thing can occur or another can occur. So for example, if I want my coin to land on heads, or if I want my spinner to land on a 4, I'm happy with either of those outcomes. So let's say my coin doesn't land on heads, but my spinner lands on a 4. That's okay, because I'm happy with either or. So the example we have is you roll a number cube. What is the probability you roll an even number or a 3? So whenever we see this word or, that means that we are going to add our two probabilities together. That's why we have this down at the bottom, very important. Or means to add. So anytime you see that keyword, I would highlight it and I would write what operation you are doing above it. That way it stands out and you don't get confused because they can get confusing. So the first thing you want to do is find the probability of each event. So the first thing that we want to happen is the probability that you roll an even number. So we know on a number cube, they are numbered, all of them, 1 through 6. So the probability of rolling an even number is 3 out of 6, or we can reduce it to 1/2. That is the probability, because out of the 6 numbers, 3 of them are even. So we found the probability for one thing. The next thing we want to do is also find what is the probability you will roll a 3. So the probability of a 3 occurring is 1/6. 1 out of our 6 numbers is 3. So what we need to do now, since we have our keyword or, which I circled and I put a plus sign in front of, so I'm going to add my probability of rolling an even number, which originally was 3/6, plus the probability of rolling a 3, which is 1/6. And since my denominators are already the same, I'm going to keep them the same going across. And then I just need to add my numerators. So 3 plus 1 gives me 4. Now, remember, you must simplify your fraction. So it would reduce down from 4/6 to 2/3. So there's a 2/3 probability that I can roll an even number or a 3. The next event that we have is an AND event, or it's called an overlapping event. And these are events that have at least one common outcome, meaning I really want both things to happen. For example, I want to get $100 and I want to win the lottery. I want both things to happen. I'm not going to be happy with just $100 or winning the lottery. I want them both. So if they are overlapping or AND events, you must always multiply. This is another one where you're going to have to circle those key terms. So we know that AND means to multiply. Alright, so for example, you roll a number cube. What is the probability you will roll a 2 and a 5? So I'm automatically going to underline, circle, highlight, do whatever to my keyword and I'm going to write the operation above it. So and is multiply, or is add. So we're going to do the same thing we did last time. The only difference is the operations. So we need to find first the probability of rolling a 2 on a number cube. Out of the 6 numbers on the number cube, only one of them is a 2. So the probability of rolling a 2 is 1 out of 6. The next thing I want to know is the probability of a 5. So my probability of a 5 is 1 out of 6, because only one out of my 6 numbers is a 5. And then finally, we are going to multiply the two probabilities. So we're going to do 1/6 times 1/6. Remember, multiplying fractions ain't no problem. You multiply the top, then you multiply the bottom. So we do 1 times 1, which gives me 1, and then we do 6 times 6, which gives me 36. So I have 1/36 of a chance of rolling both of those. So I have a higher probability of getting my 3 or an even number versus getting a 2 and a 5. Okay, so now for the exit ticket. You guys do not have to worry about doing 3 because I'm a dingbat and 3 and 2 are asking you for the same exact thing. Alright, but number 1 says, what is the probability that you will roll a 3? So we want to roll a 3 or a 6. So the keyword or, remember, that tells me to add. So first we find the probability of rolling a 3. On my number cube, I only have 1 out of 6 numbers that are 3, and then I need to find the probability of rolling a 6. And 1 out of my 6 numbers are a 6. So then I need to add them together. So we have 1/6 plus 1/6, which gives me 2/6, which I can reduce to 1/3. Alright, the next one says you roll a number cube and flip a coin. What is the probability you will get an even number and land on tails? So first we find the probability of getting an even, which is 3/6, or you could reduce it to 1/2. And then we need to find the probability of tails, which is also 1/2. And then since we have our keyword and, we're going to multiply them. So you have 1/2 times 1/2, which equals 1/4. So again, if you were comparing these probabilities, the probability of rolling a 3 or a 6 has a greater chance of happening than rolling an even and flipping a coin landing on tails. So just make sure that you are highlighting key pieces of information. Maybe highlight the first event in one color, the second event in another color, and then circle those ors or ands and write your operations above them. That way you are organizing your work. Alright, and that's all we have for compound probability.